Bismillahirrahmanirrahim. Dr. Mohammad Yusuf from the Department of Chemistry, Islamic College, Peshawar is here. Today, the topic which we will discuss is nomenclature of ketone. In common system, ketones are named as alkyl ketone. That is, alkyl is named first and followed by the word ketone. For example, here it is methyl. The compound will be termed as dimethyl ketone. And here, look, it is ethyl and it is also ethyl. Therefore, the compound is named as diethyl ketone. That is common system. Only in common system we use the word alkyl followed by the word ketone. Here, if you look, both the alkyl groups, they are similar here, but in this case one is ethyl, the other is methyl. While naming such ketones, there are two rules. One is seniority order. By seniority order, we means the smaller alkyl group is considered a senior group. Remember, the smaller alkyl group is considered as senior alkyl group. Therefore, it is named first, and the bigger alkyl group is named as later on. So here the name will be methyl ethyl ketone. Methyl ethyl ketone. This is seniority order. Remember, in common system, mostly this seniority order is preferred. But in our book, even alphabetic order is followed here in the common system, which is mostly adopted by the Ipac system. So in our book, it is ethyl methyl ketone. Here it is named in alphabetic order. And this is the common system of the ketone. Now, Ipac system of ketone. Here only one word from the alkane should be replaced. That is, E is replaced by the word on. E is replaced by the word on. So it becomes alkanone. Here instead of E, we will be having on. It will become alkanone. Alkanone. If it contains 3 carbon like this one, then it will be propanone. Remember, propanone is the first member of the ketone series. Similarly, it contains 4 carbon here, therefore it is termed as butanone. Here, if this carbonyl group is numbered, it is at position number 2, and if it is on this side, it will always be also be at position number 2. Therefore, no need of numbering in case of butanone. But if the number of carbon become greater than 4, for example, here you see we are having 5 carbon, then you have to start from the side which is near to the carbonyl carbon. So here this numbering should be starting from here 1, 2, 3, 4, 5. So here we are having a branch at position number 4. Therefore, the name of this compound will be 4-methyl 2-pentanone. 4-methyl here, 2 functional group is here, and the compound contains 5 carbon. It is then 4-methyl 2-pentanone. Here, if the compound contains more than 2 ketonic functional group like this one, if it contains 2, it will be termed as dione. And if it contains 3, then it will be trione and so on. But keep in mind, you have to start numbering the chain from the side which comes first. That is, the functional group is near to that end. So here it is at position number 2, and from this side if you start, it is position number 3. So preferably we will start from this side and it will become 2 or 4. Hexa. It contains 6 carbon, therefore 2,4 hexadione. Preparation of aldehyde and ketone. Aldehyde and ketone can be prepared by 4 methods given in our text. One is the ozonolysis of alkene. Ozonolysis of alkene. We have already discussed this reaction in the properties of alkene. Ozonolysis is the addition of ozone. Addition of ozone to alkenic double bond. Alkenic double bond is called ozonolysis. This ozone is added at the position of the double bond. Here I have taken this alkene as German, and I have labeled these 2 carbon as carbon 1 and 2. This is one fragment and this is another fragment. Ozone is added at the position of double bond. So here we get ozonide. Ozonide means here the carbon-carbon double bond is broken and you get this cyclic structure. This cyclic structure is called ozonide. 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 This ozonide, on reaction, on heating with zinc and boiling water, it undergo cleavage like this one to give zinc oxide, and 2 fragment. This is fragment number 1 and this is fragment number 2. Remember, the nature of this fragment and this fragment will depend upon the group attached over here with these carbon. Let's suppose here in this compound we are having R and R, right? So here we will also be having R and R, and you will get a ketone. But in this fragment, let's say we have one R and other is H. So this fragment we will get R and H. So this is aldehyde. Therefore, we can get both ketone and aldehyde together. Only ketones if all the groups attached here and here, they are alkyl groups. And you can get just aldehyde if all the groups here, here and here, they are either one of them is hydrogen or both are hydrogen. Therefore, this ozonolysis can be used to prepare both ketone and aldehyde. And keep in mind, this topic is very important from MCQ point of view, because sometimes you may be given an alkene over here and you have to find out which product is from over here and which product is from over here. So the product which is from here and here, it will depends upon the nature of the group attached to this carbon and attached to this carbon. If you know the nature of these groups which are attached to the doubly bonded carbon, then you can easily identify which kind of product can be obtained during the reaction. This is one way by which you can prepare aldehyde and ketone. Second is a hydration of alkyne. I have taken terminal alkyne here, terminal alkyne. Remember, terminal alkyne will always give rise to aldehyde. terminal alkyne will always give rise to aldehyde upon hydration. So first, let's say what is meant by hydration. It is the addition of water, addition of water, addition of water. Water is added to the triple bond, carbon-carbon triple bond. The carbon-carbon triple bond is at position number 1, and that's why it is known as terminal alkyne. Here, hydrogen is attached with this carbon according to Markovnikov rule, and OH become attached over here. This reaction takes place in the presence of 10% H2SO4 and mercuric sulfate as a catalyst. So here H become attached with this carbon and OH become attached with this carbon. You get this compound. This compound then undergo rearrangement. How? The lone pair of electron and oxygen is shifted toward carbon, and the double bond is shifted toward this carbon. We get this negatively charged carbon, and since oxygen is having 3 bonds, therefore it must be a positive charge. This again undergo rearrangement. In this rearrangement, this hydrogen is broken. This hydrogen is shifted from here toward this carbon, and you get RCH. This is H come here, it become attached over here, and this C double bond OH, and we get aldehyde. So again I may repeat, addition of water to terminal alkyne will give rise to aldehyde. The arrangement is like this one. H become attached over here, OH become attached over here. Then oxygen shift its lone pair of electrons toward this carbon. Pi bond is shifted toward the carbon. Carbon become negatively charged. Oxygen bear positive charge here. The oxygen hydrogen bond is broken. This hydrogen shifts over here, and you get aldehyde. Now let's say we are having non-terminal alkyne. I will just change only here, say non-terminal alkyne, non-terminal alkyne, non-terminal alkyne, or you may call it substituted alkyne. So this H will be changed into R, let's say R, right? So this H will also be changed into R. The rest of the reaction or the story is exactly the same, only change this H into R, and here change this into R, you will get ketone. So here you got 2 things. One, terminal alkyne will give rise to aldehyde, as I have told you before, and non-terminal alkyne on hydration will give rise to a ketone. The third method is oxidation of alcohol. Alcohol can be oxidized into aldehyde and ketone. Aldehyde and ketone. This oxidation takes place in the presence of acidified KMnO4. Acidified means that is either in H2SO4 or HCl. Acidified KMnO4 is used as oxidizing agent, or potassium dichromate is used as oxidizing agent. By oxidizing agent, we mean that KMnO4 and H2SO4, both of them, they react and they liberate this nascent oxygen. That's why it is known as oxidizing agent. So from alcohol, we can prepare aldehyde and ketone by the oxidation of alcohol with strong oxidizing agent like KMnO4, an acid medium, or potassium dichromate in acid medium. How? Primary alcohol, if we take primary alcohol, then it is oxidized to primary alcohol is oxidized always to aldehyde. Keep in mind, aldehyde. Primary alcohol on oxidation with strong oxidizing agent will give rise to aldehyde always. If we take instead the secondary alcohol here, this is the secondary alcohol here, you see this is secondary carbon. So in the presence of the same oxidizing agent, it will be converted into ketone. So this point should be kept in mind. The primary alcohol on oxidation will give rise to aldehyde, and secondary alcohol on oxidation will give rise to ketone. That's why we can prepare both aldehyde and ketone from oxidation of alcohol. As far as the Friedel Crafts acylation is concerned, you may have studied it in the benzene chapter in aromatic electrophilic substitution reaction of the benzene. Here, benzene contains pi electron, and these pi electrons will attack on the acyl carbon here, and substitution reaction will occur in benzene, and you will get this ketone. This reaction takes place in the presence of Lewis acid as a catalyst.